user space. We have to wait for it to pass a health check. Then the Kubernetes will schedule a pod, and we can start pulling the container image. Then we can run the container, and then the workload will start to start remediating load, start to see the benefits of our scale. But what you're seeing here is within 30 seconds, I'm able to get these workloads running automatically with no VMs. Every workload's hypervisor isolated. You pay per second, and its responsiveness is really unparalleled. There's nothing like this out there. So this is really exciting to me for a bunch of reasons. So Brendan talked a lot about serverless Kubernetes and nodeless Kubernetes at KubeCon in Shanghai. And so I was with Brendan in Shanghai not that long ago. And I want to be clear about a few things. One, the pods that are running this in this demo, they are just like any other pod. If you ran these on Minikube or on on-prem Kubernetes or on GKE or wherever, it will work the same way. Brendan and I, come from open source. We would not do this. I'm sorry, Brendan and I. Do you guys know who Brendan is? No. Okay, sorry. I always forget that. Brendan is my counterpart in engineering. In Microsoft, they split the function in engineering between PMs and development, right? And PMs do strategy and sort of roadmap and spend most of the time with customers and that sort of thing. The developers, they do the hard work. They get the job done, they write the code. My pair in this relationship is a guy by the name of Brendan Burns. Anyone here know Brendan Burns? No? Okay. Brendan is the co-creator of Kubernetes. So Brendan created Kubernetes when he was at Google. He now runs engineering with me at Microsoft for all of our container pods. He's actually, Brendan, by the way, is the only original co-creator of Kubernetes still working at a cloud provider. The other ones, Craig and Joe, also folks I work closely with, now work with VMware. So anyway, Brendan talked a lot about this future of serverless Kubernetes, and coming from Brendan, this means a lot, given that he had a hand in the creation of this. So yes, this works anywhere on any environment, and the other point I was going to make here is this project is actually enabled by something called the virtual kubelet. The virtual kubelet is now a CNCF project, and you'll notice that the providers for this, yes, we have the Azure Container Instances provider, and we obviously helped create this project. But AWS has their provider for Fargate here, and we work closely with AWS on this. We work closely with VMware on this project, and they don't have this. Alibaba has their own provider for their Elastic Container Instances service. This is a trend in the industry. The only one, frankly, of the big cloud providers who hasn't done anything here is Google, and they don't have an offering in this area. But most other providers are doing something in this space because, frankly, the benefits of hypervisor isolated containers operated at cloud scale are quite compelling. I think probably the most compelling part about this demo is not what I just showed you, is this. When I scale the replica count back to 0. Because a lot of people who are looking at burst scenarios, they're concerned, yes, they're concerned with responsiveness and how fast you can burst the workloads, of course. But they also want cost controls, to your point before. How fast can you get your cost controls down? So I just scaled, you can already see the replica count starting to come down. But really, the containers are already stopped. You stopped paying for them. It's just the front end hasn't gotten updated yet. It takes a minute for this to cycle out. So the scale down is instant. You stop paying instantly. And you don't have to worry about managing pools of capacity anymore. So fast forward a little bit, and where do we go with this, right? What's the ultimate picture here? Let me paint a product experience for you. You show up at Azure looking for an AKS cluster. You get one provisioned in about 30 seconds. There's no VMs attached to that cluster at all. Every time you run a pod, Nginx or WordPress or whatever, you pay for however many container seconds you want for that pod. And when you kill it, your costs go down to 0. You can always add VMs if you want to manage VM pools, and there's lots of good reasons why you might want to do that. But I believe very firmly that serverless Kubernetes is a future that a lot of customers I talk to are very interested in. I'm very interested in as a user. And it's something that I think you're going to see from Azure for the most. Cool. Any questions on serverless Kubernetes?
This is, can we have this in the Azure Stack as
well? No, unfortunately. The answer is no. And part of the reason why is that we do a lot of interesting work behind the scenes to plug, because if you think about a cloud, there's so much hardware. I mean, even the small data centers are just absolutely jam-packed. And there's lots of little corners of the data center where you can fit one virtual CPU and 512 megs of memory, right? And so being able to do really granular bin packing is part of the reason why I'm able to price this the same price as VMs. Because one of the other things I didn't talk about is before, when we first came out with ACI, it had it was like a 60% premium on top of what we pay for VMs. But what we heard from customers was, I love this, I want to use this, but it's too expensive. So we said, fine, we're going to make it as cheap as VMs. And so that's where we are now. But on Azure Stack, I don't have holes in the infrastructure to fill. So it's harder. But one of the things you could do is you could actually burst from Azure Stack out to global Azure. And that's one thing that I actually have a number of people doing. I have a lot of folks who are using exactly what I showed you from their own on-premise Kubernetes deployments, running in their own data centers. So they're bursting to ACI. Interestingly, one of the hardest parts about building this system was actually not the compute layer, because it turns out that it's fairly easy to build the virtual kubelet. If you look at the code base, it's not that hard. It's fairly easy to build a serverless container runtime using hypervisor technology. Not that it's easy, but it's sort of, it's understood how you do that. What was very hard was how we made the networking work. Kubernetes has very complicated networking, IP per pod. It has, who you remembers when Kubernetes first came out and everyone looked at IP per pod and they were like, what? I have to assign a /24 for every host on my network to use this thing? Or I have to run an overlay like Flannel to use this thing? That's garbage, right? Well, it turns out Kubernetes was right. You actually, it works a lot better, but making that work with ACI was very tricky. We had to engineer solutions for Kubernetes service virtual IP. Every time you define a service in Kubernetes, you get a virtual IP assigned to that service, and it will dynamically load balance across all the pods. So we had to solve for VM to ACI, VM to Kubernetes service to ACI, ACI to Kubernetes service to VM, and all these different network flows that were actually really complicated. And Kubernetes service discovery, kubedns, all of it works seamlessly. And so that what's great is that from a networking perspective, you can run retail. Some of my biggest customers on this are actually retailers who use this for Black Friday bursting. Imagine this for that, right? Why do you need to manage VM capacity when you can just burst direct to these containers? By the time your VM autoscaling is in the red on CPU or memory, your customers are already having a bad time. They're already having slow page loads, right? So if you wait that long, it's not great, right? So being able to burst direct to the container means you're able to recover and get back into your SLO much, much faster. So retail ends up being a big use case. Interestingly, we also support GPUs with ACI. So we have a lot of people who are doing model training with this as well. So they can use Kubeflow, they can use GPU-based model training, but have it burst onto this so they don't have to pay for very expensive games. Okay.
Gabe,
yes.
One of the arguments of our customers when they think about containerization over VMs instead of serverless is vendor lock-in. So how do you think this technology could help to fight those arguments?
Yeah, I think that, well, a couple of things I would say. One is, Brendan and I were very adamant that this not be a lock-in thing, right? We wanted it to be, hey, look, if you use Azure and you annotate your workload specially, you get this magic speed thing, right? And magic isolation. And so that was a very important philosophical approach for us. But I also think another question in there is, what is the definition of serverless?
Yeah.
Right? Right.
That's what I mean. What are your feelings about those other tendencies about serverless, like functions or lambdas or everything? How does relate with this?
It's a great question. So like what I would say is I travel around the world, right? I view my job as part manager, and then the other part of my job is listening to customers and seeing patterns happening in the wild. And one of the big patterns that I see is that functions are being used to glue Kubernetes environments and AKS,
Right.
specifically with other systems, right? Functions are really a terrific way to build integrations between different systems. I am less convinced that functions are a great way to build anything beyond simple applications, right? Maybe basic HTTP applications, like a static web serving, or some basic processing. But chaining together 15 different functions off of an event stream is complicated, right? It works for some environments, and yet in others I think it's a little bit more challenging. For me, I'm always biased towards what is the most operable solution, what is easiest to operate. And I think that functions is not yet proven as to how you operate large-scale apps. How do you debug them? How do you, do security and governance in them? There's still a lot of stuff. It's new, right? A lot of stuff that needs to get figured out. I can point to a lot of people who are using Kubernetes at scale, but with functions as well.
But I think when they say Lambda functions, they're thinking about functional programming.
Yeah, and
functional programming is equivalent to Turing complete programming. So Turing complete computing. So basically, my question is, how do you manage error?
How do you manage what?
Error.
Error. In which, what do you mean?
When you have different containers doing different things, how do you manage error?
Well, I mean, it's hard to manage errors in any environment. Obviously, step one is making sure that you have good monitoring, telemetry, and alerting. But the errors will happen.
With a log?
Log.
With a log feed.
I'm sorry, I might be misunderstood.
A log feed is like feeding the log and having all the log in the same place, basically.
Oh yes, log aggregation. Yes, log aggregation. Ultimately, there are some systems out there that can do. We have our own systems inside of Azure for this, but that can do correlation across metrics, across logs, across alerting. Right, so you can ideally plot those in one tool, and distribute tracing as well. Ultimately, you need that kind of infrastructure if you're going to be doing very sophisticated applications. Most people don't have access to that kind of tooling like we do inside of Azure, that you have in Google or Amazon. It's very, very hard to build those tools. There are new things coming out. Open Tracing has some interesting investments. Zipkin is used by some large companies. Uber, for example, uses Zipkin, I believe, for their tracing infrastructure. But there's no easy answers. But I do think when...
So there's no promise in Docker?
There's no what?
Promise?
Promise. No, I mean, look, Docker is fundamentally an infrastructural concept. It is not a programming model. And I think when people talk about functions, and what they're really talking about is a programming model that happens to have an infrastructure opinion associated with it, right? The way I like to think of it is, because you can do functional style application design with containers. It's just, it's up to you, right? Containers can run anything that VMs can, more or less. But for me, I actually think that functions programming model is actually kind of restrictive. Who here has ever written evented code? Here's a developer and written like evented. Has you ever written evented code? Right, it's all callbacks and that sort of model. Right. And then sometimes you start writing evented code and you're like, oh, this is great. I wrote a lot of like twisted Python and C, like epoll event loops and stuff like that, and it's fun. And some problems are really well suited to that model. And then other problems you start out writing it evented, and then you're like, oh wait, you know, this is a tangled pile of callbacks, and if I write it as a synchronous program with some threads, it's like 10 lines and super easy to understand, right? And so the same thing is true with the functions programming model. Works great for some things, and for other things it's not a good fit. That's why we have choice in programming language. So the thing that annoys me the most about the functions sort of effort is this idea that everything can be modeled with an invented programming model style. That's not true. There's a whole class of applications, machine workflow pipelines, for example. Right? You just can't model that stuff with Lambda or with functions. It doesn't work, right? There's other areas where you want to do a bunch of background processing, where you need to longer than 15 minutes or whatever the amount of time is, right? Where you need the concept of a thread in sort of a programming process that needs to run in a container typically, right? So anyway, I have my own opinions on this.